Hello PU2 champions, welcome to day 9 of 21 days challenge to get 95% in second PUC board exams. So as part of today's challenge, I have given you two chapters for homework, Ray Optics and Optical Instruments from Physics and Application of Derivatives from Mathematics. So you need to revise these two chapters and practice its most important questions from the PDF I have provided. The link is there in the description section. You can click on the link, go to the page and download the most important questions PDF if you haven't yet, and then practice these important questions definitely. Now in this video, I'll be giving you the most important questions from the chapter Ray Optics and Optical Instruments. And as you have suggested to give the answers for the numerical questions, so I have included answers as well. Okay, so let's see the most important questions. But before that, we have to understand the blueprint of this chapter. So the weightage of this chapter is 10 marks, okay, and you will get one 5-marker question, one 3-marker question, and two 1-marker question. Now in this 5-marker question, the one question that will be asked, it can be either numerical or a theoretical questions. Okay, so if you see model question paper, in two of the model question paper we have numerical question, and in one model question paper you have the theory question. Okay, so you have to practice both. Now let's see. Okay, before moving ahead, so children, we have just 75 days left for your KCET 2026 examination, and to get a good rank in KCET, to secure a top seat in top college, then something which is very important apart from studying is practice. Okay, the more you write the test, that to relevant test, you will be more confident for the exam. So to help you with this, I have launched the Fighter KCET 2026 test series, and these test series are designed by KCET experts in the KCET pattern and KCET syllabus, and you will get total 18 mock tests, including 6 from physics, 6 from chemistry, and 6 from maths. Apart from that, detailed solutions, test analysis reports, and of course the video solutions for chemistry test will be provided. So you can afford, get all these things at a very affordable price of just rupees 399. Please remember, it is just 399, which is very minimal, and the link is there in the description section. So if you are searching for a good affordable test series for your KCET 2026, then this is the best possible option for you. So click on the link and then register and then purchase this test series so that you can practice and feel confident about your exam. Okay, now let's move to the most important questions, 5-marker theory questions. So first one is you have to derive the lens maker formula. Then this question you can see has been repeated for years. Then derive the expression for refractive index of the material of the prism in terms of the angle of prism and angle of minimum deviation. Next, deduce the relation between n, u, v and r for the refraction at a spherical surface where the symbols have their usual meaning. Derive the expression for the equivalent focal length of two lenses kept in contact. Derive the mirror equation 1 by f is plus 1 by u equal to 1 by f. Now we'll see some numerical questions from 5 markers. So a parallel beam of light is incident on one face of an equilateral prism. By rotating the prism, the angle of minimum deviation is measured to be 40 degree. Now determine the refractive index of the material of the prism. If the prism is immersed completely in water, calculate the new angle of deviation. So the angle refractive index is 1.532 and the new angle of deviation will be 10.4 degree. Next, question number 2. A ray of light passes through an equilateral glass prism such that the refracted ray inside the prism is parallel to the base. Calculate the angle of deviation of the ray and the speed of light ray inside the prism. Okay, here are some data given to you. So the angle of deviation is 37.18 degree and the speed of light inside the prism is 2 into 10 to the power of 8 meter per second. Next, an object is placed at the bottom of a slab made up of transparent material of refractive index 1.5. The object is viewed normally from the top where it appears to be raised by 20 mm. Find the height of the slab, which is 60 mm. Okay, the answer you will get. Next, a convex lens when placed in air has a focal length of 0.4 meter and refractive index of 3 by 2. What will be the focal length when immersed in water of Ri 4 by 3? Here you will get the answer of 1.6 meter. Next, two lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Find the focal length of the combination and calculate the power of the two lenses and combinations. Okay. Next, an object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, by how much distance is the image displaced? Next, a small bulb is placed at the bottom of a tank containing water of a depth of 80 cm. What is the radius of the circular surface of water through which the light emerges out, refractive index of water is 1.33. Next is, okay, this is I think a repeated question. Once again, 6 7. Okay, no. A small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter. What is the radius of circular surface through which the light emerges out? Refractive index of water is 1.33. Okay, so yes, this question is repeated. You just need to solve it once. Okay. Next, the radii of curvature of two surfaces of a convex lens of 0.2 meter and 0.22 meter. Find the focal length of the lens if the refractive index of the material of the lens is 1.5, and also find the change in focal length if it is immersed in the water of refractive index 1.33. Next, we have double convex lenses to be manufactured from a glass of refractive index 1.52 with both faces of same radius of curvature. What is the radius of curvature required if the focal length is 25 centimeter? And what will be the new focal length when the lens is immersed in water of refractive index 1.33? Next, an object of height 3 centimeter is placed 14 centimeter in front of a concave lens of focal length 21 centimeter. Find the position, nature, and the size of the image formed. Next, a prism of angle 60 degree produces an angle of deviation of 40 degree. What is refractive index, and calculate the angle of incidence. Now we'll see the 5 marker model question papers of 2025-26 papers. So in model question paper 1, double convex lens are to be manufactured from a glass of refractive index 1.5 with both faces of same radius of curvature. Find the radius of curvature required if the focal length is to be 20 centimeter. Also find the new focal length if the lens is to be immersed in water of refractive index 1.33. Okay, so this similar question is already we have discussed. Model question paper 2, question number 45. Find the effective focal length and effective power of a combination of convex lens of focal length 25 centimeter in contact with a concave lens of focal length 20 centimeter. Is the system converging or diverging? Ignore the thickness of the lens. Next, model question paper 3, the question in the 5 marker section was a theoretical question. Derive the expression for refractive index of the material of a prism in terms of angle of prism and the angle of minimum deviation. Okay, now we will see 3 marker question. Give the sign conventions used in geometric optics. Prove that the focal length of a spherical mirror is half of its radius of curvature. Give any 3 applications of optical fibers. A small telescope has an objective lens of focal length 1.144 centimeter and the eyepiece of focal length 6 centimeter. What is the magnifying power of the telescope? Next, 3 marker model question paper 1. The question was, draw the ray diagram for the formation of image or by a compound microscope. Write the expression for the linear magnification produced by the objective of compound microscope in terms of its tube length. Next, model question paper 2, question number 34. Give the Cartesian sign convention used to measure the distances and heights in the spherical mirrors. Model question paper 3. So that the focal length of spherical mirror is equal to half of its radius of curvature. So children, these are the most important questions, and once again, if you are searching for a good, affordable and relevant KCET test series, the link is there in the description section. And please do not ignore test series. You cannot qualify exam with a good rank by just studying. Okay, you need to practice, and that too from a relevant source. So please do check it out. The link is there in the description section. Thank you so much for watching, and please practice all these important questions and get prepared for the exam. All the best. Keep learning, keep working hard, and keep shining. Thank you, and see you soon in the next video.